What's up, guys? It is Friday, April 17th, and today we're just going to start part one. We're going to do about half of the 10.2 lesson. The 10.2 lesson is going to be how to solve square root equations. So any equation that consists of a square root expression, we're going to be solving those today. All right, pretty simple rule. All right, to start with today. So again, we'll just do part one. Let's start by writing down our learning target, which essentially tells us exactly what we're going to do here to solve these, okay? Which is I can solve a square root equation by isolating the square root expression and squaring both sides. All right, so that's how we're going to do this. So let's look at, we're going to do examples 1 and 2, and then we're going to have you guys practice it. All right, so let's read this together at the top of the page quick. A square root equation is an equation that contains a square root with a variable in the radicand. Remember, that just means that there's an expression with an x or a variable underneath the square root symbol. All right. To solve a square root equation, use properties of equality to isolate the square root by itself on one side of the equation. And then we're going to use the following property, which the following property says to square both sides of that equation. Okay. So we're going to get the expression that consists of the square root on one side of the equation alone, and then we're going to square both sides. Okay, so down here, key idea, squaring each side of an equation. If two expressions are equal, then their squares are also equal, saying that if two expressions are equal, then if we square them both, we get the same answer, or they're still equal. Okay, so this is an algebraic way of looking at it. If a equals b, then a squared equals b squared. Okay, kind of a basic rule. All right, so let's look at example 1. It's the most basic type. And here's what we're going to do. All right, we are going to try and isolate the square root of x first. All right, so pretend that the square root symbol wasn't there. What would we do? We would subtract this 5. All right, from both sides of the equation to get this square root expression alone. Okay, so this one's pretty simple. We're going to subtract 5. All right, subtract 5 from each side. We're left with the square root of x equals 8. All right, so here's what we want to do. Now we got to get rid of the square root symbol. I just want to know what x is. Okay, so we're asking the square root of what number is 8. So we can find that, and we can get rid of the square root symbol by squaring both sides of the equation. Okay, remember, squaring is the inverse operation of taking the square root. So that's how we get rid of the square root symbol. All right, we're going to square both sides. That's going to give us x equals 64. All right, and that's our answer. Okay, solution is x equals 64. In a minute, I'll show you that you can always check your answer, of course. Here it is. So again, if we plugged in 64 to the original equation, does it work? Well, the square root of 64 is 8, and 8 plus 5 does equal 13. So we can check our answer that way. Okay? All right, let's try one where there's a specific rule that we have to use. All right, so there's a couple ways we could do this. Easiest way is the way the book shows, which is what we could do is just to refrain from using negatives at all, why don't we just add the square root of x to the other side of the equation? Okay, which is entirely possible. We can do that. It's actually the fastest way to solve this. All right, so that's what they did. They added the square root of x to each side of the equation. Okay, then we can square both sides and we can get our answer as x equals 9. All right, so our solution is x equals 9. So real quick, I want to show you another way you could do this. Might take a little longer, but I want to show you a really important rule. All right, so let me rewrite this. 3 minus root x equals 0. Another way we could have done this is we want to isolate this, right? So some of you might say we want to subtract the positive 3 to get rid of it. But that's going to leave us with a negative square root of x equals a negative 3. Okay? What we have to do right now is we have to pretend like there's a negative 1 here. Okay? And we want to get rid of this negative sign before we square both sides. Okay? There should be absolutely nothing left other than the square root expression. Okay? So this negative, we got to get rid of that too. Really, really common mistake is we square both sides first to get 9 and then divide. and we get negative 9, and that's actually incorrect. Okay, a really common mistake. So we want to get rid of this negative sign. So I would divide by negative 1 to do that. Okay, divide by negative 1, which would leave me the square root of x equals positive 3, and then we would square both sides to get 9, okay, to get x equals 9. All right, but I just wanted to show you that really important rule. This negative sign's got to go before we square both sides, okay? All right, let's look at an extra example quick. And I'm going to fly through A because it's simple. If we subtract 1, we want to isolate this, right? We want to isolate this. If we subtract 1, we get 3, and then we square both sides and we get 9. Okay? But now I want to look at this bottom one. Get this out of the way. All right, this bottom one says 7 minus the square root of x equals negative 5. So what we want to do, or an easy way, is we could add the square root of x to the other side and add the 5 to the other side, which would leave us square root of x equals 12, and then square both sides. Okay, so that would give us our answer there. All right, okay, let's have you guys give it a shot. So these on your own questions, let's try all of these. All right, and again, focus on that same rule for number 4 here. All right, let's try all of these. So at this time, pause your video, and when you come back, your answers will be up. All right, so x equals 36, x equals 100, x equals 49, and then x equals 9. Okay, and real quick, I want to show you number 4 and how we could do this. All right, so what we could do is we could subtract 1 to get rid of it from this side, but again, that's going to leave us a negative square root. So this is one of the ways we could do it. It's going to give us negative 3, but remember, before I square both sides, I have to divide this. Okay, I want to divide by negative 1 to get rid of the negative sign, which would leave me root x equals positive 3, and then I would square both sides to get my answer here of x equals 9. All right, that's a really important rule, okay? Okay, next example. And this is the last one we're going to do today. All right, so what happens when there's all this stuff on one side of the equation? Here's how I picture it. I pretend that this square root, this expression, is like a big variable that I'm trying to isolate. Okay, so we've done things like this year. If I want to isolate the square root expression of x plus 2, right? I'm going to pretend it says this. And I'm going to follow the same exact steps. I'm going to pretend like this expression is just an x, because that's what we want to isolate first. So I'm going to pretend it says this. How would I solve this? By subtracting 3, getting 4x equals 16, and then dividing 4 and getting x equals 4. Okay, now there's a little bit of a difference, is the fact that I'm going to be left with the square root of x plus 2 when I follow the steps in this problem, but the steps are the same. I want to subtract 3. Okay, so I'm going to show this. I'm going to subtract 3, and then I'm going to be left with, let me split this up. And I'm going to be left with 4 root x plus 2 equals 16. All right, and I'm going to do the same thing. I'm going to divide 4, just like I did over there. Divide 4, but like I said, now the difference is I'm left with the square root of x plus 2 equals 4. Okay, so I don't just get my answer right now. Now, since I have this isolated, this is where I'm going to square both sides. All right, I'm going to square both sides. That's going to leave me with just x plus 2 now. Remember, that's the whole point of squaring, is to get rid of the square root symbol. Equals, now I'm going back to getting 16, right? So I have 16, and now I just solve for x completely, okay? So I subtract 2. subtract 2. So in the end, my answer for this problem is x equals 14. Okay, so we've done things like this year, right? Where we had like absolute value and we tried to isolate that. It's kind of the same concept, all right? So let me get rid of that and then show you again quick from the book. Okay, so again, what did we do first? Subtract this 3. Then we divide by 4 to get this alone. Remember, we want this expression by itself. Now that we have it alone, we're going to square both sides. Okay, that's going to give us just x plus 2, no square root symbol anymore, equals 4 squared, which is 16. And now I can subtract 2 to get my final answer of x equals 14. All right, so hopefully that made sense to you. I'm going to have you guys try this one, actually. So right now, pause your video, and then when you come back, I'm going to work through it with you, okay? All right, so hopefully you were thinking that first thing we need to do is add 6. Add 6, that leaves me 3 square root of x plus 1 is equal to 15. Now I got to isolate the square root expression, so I'm going to divide 3. Divide 3, leaving me now I'm over here, x plus 1 equals 5. Now that I have this alone, that's what I want, so that I can square both sides, leaving me x plus 1 equals 25. 25. And then I'm going to subtract the 1 to get x equals 24. Okay, so that's all we're going to do today is we're going to stop there. And hopefully that made sense. Now you guys are going to go into, you're going to do a big ideas practice today. So it's called 10.2 practice part 1. Again, in big ideas. There's 8 questions, I believe, that we're going to complete today that are going to help us meet that learning target. But as always, if you have questions, ask in the discussion thread or email me. Otherwise, I'll talk to you guys tomorrow.